Why aren't more people using dApps? Well, I want to focus on one reason that could be holding back mass adoption of blockchain technology, all right? And that's user experience. There's all these hoops people have to jump through in order to even use a blockchain-based application. But I've just learned about a solution that could solve all of this and make it so user-friendly so that even your grandma could use this on a smartphone. So before we get into that, hey, if you're new around here, I'm Gregory from Dapp University. On this channel, I teach you how to build blockchain technology. So click the like button down below and click subscribe, especially if you've been watching this channel, because I've got access to my YouTube analytics, and it says a lot of you aren't subscribed. So I don't know what you're waiting for. Hit that button down below. So like I said, there are a few things that are holding back blockchain applications from gaining mass adoption, really being ready for prime time. And one of them is user experience. So what is this problem? Well, in order to use a blockchain application, somebody has to visit a website, and then that website's going to say, hey, go install a Chrome plugin or some other web browser in order to even access this, all right? And that's causing almost everybody to turn away. So some data released by the CryptoKitties team showed that they had a 99% drop-off rate whenever people first visited their site, all right? So this is a huge deal. Almost everybody who goes and tries to use a dApp for the first time who's not already proficient with blockchain technology just bounces immediately. And that's because they have to go install something like MetaMask, right? Now, MetaMask is a great tool. I'm not knocking it, but it is a bottleneck that's preventing a lot of people from using blockchain applications. So what is the solution to this, all right? Today, I want to introduce you to Ethereum, okay? This is a way for you to build a blockchain application that can seamlessly onboard new users without them having to download a Chrome extension, download a new browser, or anything like that. They don't have to remember a seed phrase, and they can easily access the blockchain-based application on a mobile web browser without having to install any other special browser from the App Store. So I've invited Chris from Ethereum on my channel today to show you how you can seamlessly onboard new users to your own decentralized applications. We're going to give you a demo of how it works, how you can set it up in your own apps, and then we'll even talk about, some deep technical discussion towards the end of the video, all right? So I'm going to go ahead and hand it over to Chris, and we'll get started.
So you can see I'm in a Chrome browser right now. I don't have MetaMask or any other wallet installed. Ethereum also works right on your mobile phone. So if you have a mobile browser like Safari or Chrome, you don't have to download an extension, and you can log in with the same exact account that you're using on desktop. So here, I just hit connect, and you can see this pop-up shows up. I already have an account, so I can just log right in. And it's that easy. So now I can select a token I'd like to buy. And you can see that I have 0.1 ETH, and say I need to get some DAI to pay my friend for lunch. And then I hit swap. And there it goes.
Wow, that's incredible. Okay, so I just want to break this down really quickly in case anybody, doesn't quite understand the significance of what happened. So this is a dApp, and if you were going to use some other exchange or some other decentralized application, you would normally be using an Ethereum wallet installed in your browser like MetaMask. And in order to even use something like this, you have to go to the Google Chrome web store, install that, and you've taken all that out where they can literally just go to Uniswap, click a button, and log in.
Exactly. And we've heard that dApps will lose 99% of users when they ask users to download MetaMask. They just want to use the normal browser that they're used to. And so with Ethereum, I could log in directly with this account right on my mobile phone and still have my 5 DAI that I just bought and send it right over to my friend. Well, so this was how easy it is to log in once you have an account. But actually creating a new account if you're a new user is also really easy, and that's where I think Ethereum actually really shines, because that's the main point of friction for a lot of these dApps. Okay, I'll show you from another app we have. So this one's Kickback. Kickback is an event management app. It allows all your event participants to RSVP, and they put up a little stake, and then if they don't show up to the event, they lose their stake, and all the friends that do show up get to keep their money. So
very cool.
Here, log in with Ethereum, and then we can create a new account here, and then I'll just enter my email, create a password, and sign up.
Awesome.
So what I do from there is I validate my email address. I will skip that part for now.
Sure.
But then, you can see that right there, I have my account. I can start receiving ETH, and then I can start using a Dapp.
So can you tell me a little bit about how people can, integrate this in their own projects if they're developers?
Sure. So if you've ever built a Dapp, you're going to be building it against Web3. And so just like MetaMask, MetaMask also uses Web3 and provides a Web3 provider that it injects in the browser. With Ethereum, you just import Ethereum, and that will give you a Web3 provider. And you put that into Web3 instead of whatever's injected by MetaMask, and you're up and running. So if you already have a Dapp, it's just 2 lines of code to integrate.
Okay. So is this a JavaScript library that they can plug into their existing apps?
Yeah, so they just import Ethereum in JavaScript, and then if you have Web3 in your app, you just initiate the Ethereum object with whatever network you're on, and then create your new Web3 with the Ethereum provider, and you can start using Web3 with a normal interface. So send transaction, sign, and that kind of thing.
Yeah, very cool. So if you want to get started with this as a developer, this looks like it's really easy. Like you guys did a really great job of providing some tools that take a lot of the headache out of getting started. So, if anyone's watching and they're not quite as familiar with the old way, I've got several videos on my channel where I teach you how to use, Web3.js, build clients and applications with JavaScript. And we use the Web3 library in order to instantiate this connection to the blockchain, basically turning your app into a blockchain app. And there's a lot of setup you have to do that. And what that does is it gives you a Web3 provider that you would connect to with MetaMask or something else, that extra plugin or browser that talks to that. But this takes that extra part out of the equation, removes some of the friction of those setup steps, plug and play, click a button on your site, and you're logged in with Ethereum. Awesome. So tell me a little bit about, how this works. When you give information over, in this case, you give an email address, you give a username and a password. What happens to that information after people, get started? What happens to their funds that they send to these wallets, all that kind of stuff?
Sure. So Ethereum is completely non-custodial and censorship resistant. So those are 2 core values for us, and something that we're not willing to pass on. So all of the key generation happens client side. So it happens in the user's browser. We never see the private keys ourselves, and we never store the user's passwords. And so what happens when a user signs up is they generate a key in their browser, and then it gets encrypted with their password and with a salt. And then we store a salted and hashed version of their password on our server, so we can't know the actual password. And then we store an encrypted version of the key store on our servers as well, so that in case the user loses their key store, they can still get it from us, but we can't actually access the key store because it's encrypted and we don't have the password to decrypt it. And so once the user has created this key store, it lives right in their browser. They can also store a backup themselves, so that if we ever stop existing, the user can still access their account. And then they are up and running, and they can start using dApps with these keys. But Ethereum uses contract-based accounts. So instead of like a normal account like MetaMask where you just have your key and account, with contract-based accounts, your funds live in a contract instead of it being held by keys. And there's many keys that can access this account. With the architecture of contract-based accounts, because you have all of these keys, you don't actually hold funds in those keys. So those keys can't make transactions themselves because they don't have ETH to pay for those transactions. So the way that transactions work with contract-based accounts is that you sign the transaction data, and then you give it to a relayer. And the relayer's job is to take this transaction data and turn it into an actual Ethereum transaction, put that on chain, and then they take a refund from your account for providing that service.
That's awesome. Yeah, it sounds like you guys have really thought this through and come up with an exciting solution for this problem. I've heard about these smart contract accounts that people have been experimenting with, and this is a really impressive solution that you all have come up with.
So you can see here, here's the first key that you would generate on your mobile phone, and then you have your contract-based account. So this part's on-chain, and it keeps track of which keys are registered to the contract-based account. So then you enter a web app, say this is Uniswap, and you make your transaction. So you'd sign it with your key, give that to the relayer, which is just a service that runs, and then the relayer makes the actual transaction, takes a refund for it, and then the transaction, it sends ETH to this external wallet.
Yeah, very cool. So tell me how the relayer works.
Yeah, so the relayer is just a service, and it runs on a server, but so we run our own relayer, but then we're also going to integrate with the gas station network, which is a decentralized network of relayers. And so we have a special relayer because we provide these additional security features in our relayer. So by default, ours is used, but for the sake of decentralization and making sure that the user can't be censored by us and isn't reliant on us, they fall back on this decentralized network of relayers that is always available. And so the way these services work is they just are waiting, they're running on a server, and they're listening for transaction data. And so you give them your signed transaction data, and they're going to wrap that in an Ethereum transaction and then broadcast that to the network. And then once the Ethereum transaction gets mined, the contract-based account will verify the signatures that came from your key and then give a refund out of the funds held by the contract back to the relayer. So that's really powerful because if you have a bunch of keys across different devices and different apps, all of those keys can access the contract wallet, and all of them will refund the relayer out of the same funds that are held in the contract-based account.
Wow, I can see that really being an interesting paradigm shift. Instead of charging the fees up front, actually recouping them on the back end.
Mm-hmm. And what's really cool about that is that once we're doing that, users are no longer limited to just paying fees in Ether. So users can actually pay fees in other tokens such as DAI. So that allows us to give a really powerful experience where users that aren't necessarily the most crypto savvy can get onboarded directly with DAI, never touch Ether, and then start interacting with the blockchain and paying transaction fees with DAI, and all they see is a US dollar balance.
Wow. So everybody who's watching, in case that doesn't quite click with you, let me explain what a big deal that is. Essentially, DAI is a stable currency on Ethereum that's backed by Ether. And it's pegged to the US dollar, I'm pretty sure, right? It's one-to-one relationship between USD and one DAI. So essentially, if you want to bring in mass adoption of blockchain technology, we need a stable currency so that people can't, don't see the value of their holdings going up and down all the time for simple payments. And then also, we don't want them to necessarily have to hold two currencies in order to get started, Ether and DAI, right? Ether to pay for the transaction fees and then DAI just to send money around, right? So this is a way you can basically get your grandma using a Dapp. Log in with Ethereum, get some DAI, and then all your transaction fees are paid within the currency that you signed up with, essentially, rather than this other thing that you had to go figure out how to use.
Mm-hmm. And so another really cool thing we're doing is we're abstracting gas away. So if I just log back in with my account, and then this time I'll buy some BAT. And you can see that when the user makes a transaction, we never ask them what gas fee they want to set. And that is something that's really interesting because this is really hard to abstract away from the user because the gas fee has some pretty serious implications. So if you choose a higher gas fee, your transaction is going to get mined faster, but it's going to be a lot more expensive. And then if you choose a lower gas fee, it's going to be a lot slower. And then it might actually even get stuck in the network where when the network's congested, if you don't set a high enough gas fee, then the miners just won't pick up your transaction. And So we thought a lot about this, and we wanted to completely, take that concept and put it in the background so that the user doesn't have to think about gas. And so we're using a really cool mechanism that we came up with called gas spectrum signing to completely abstract that away. So the way that works is instead of under the hood, instead of the user just signing a single transaction, they sign a handful of transactions that have a spectrum of gas prices. So it might have a gas price of 1 gwei and 4 gwei and 8 gwei and 16 gwei. And say the market price is 1 gwei, so that's going to usually get mined in a pretty reasonable time, but sometimes get stuck. All of these transactions will all have the same nonce. So that means that they all are the next transaction, and only one of them can ever be mined. And so what we can do then, once we have this whole spectrum of transactions in the background, is first broadcast this market rate transaction that we expect to be mined in a reasonable time. But then if it does get stuck, we can then broadcast the next transaction to replace it, and then the next one until the transaction gets mined, so that we can guarantee that we find the user the best gas price, because we start at the market rate, and then we only up the gas price when the network's congested. And then the user doesn't have to think about, which gas price do I want to use, because they know their transaction's not going to get stuck, and that we'll find the best gas price for them. And then they don't even have to know what gas is, or have to understand the concept to start interacting with these dApps.
Wow, that's really impressive. Yeah, so tell me, is there anything else that you would like to demonstrate with this right now?
Sure. So another thing that you saw was, we're automatically signing these transactions. We don't pop up with an approval. That will be an option for us if users do want to improve individual transactions. But what allows us to do that is, like I said, we have our relayer that has these special security features. And so what we can do is actually run what we call a transaction firewall as part of our relayer. So when the user creates a key, we didn't get too deep into this, but there's actually a key that's created off-chain, and those keys are used for individual dApps. And that's what allows us to log into dApps so fast without making an on-chain transaction. And but once those keys are created off-chain, they're able to interact with dApps just like the other keys that we talked about. And so each of those keys is scoped to a specific domain. So this might be scoped just to Uniswap. And on our relayer, we can say, okay, this key belongs to this browser fingerprint and this domain, and can only interact with these contracts. And that way, if anything gets compromised, like say the dApp gets compromised, we can pick this up and then stop transactions from that dApp. And because we're completely censorship resistant, this is something the user can always manually bypass if they want to use the app, or they feel like we're censoring them, or we just stop existing. But when everything is working, it provides this really nice experience of not having to approve individual transactions, because we're actually doing that security and looking for malicious transactions on behalf of the user.
Wow. Yeah, that's really impressive. So, do you have any kind of plans, maybe even implement some sort of almost like conditional type of verification, right? So let's say someone comes in here and they want to send 10 DAI around. They don't necessarily need confirmation for that. But if they want to send 10,000 DAI around, like maybe is there a way to say, we want to make sure that that's verified on your behalf? Or like you see, maybe if you have a Stripe account or something like that, small amounts are fine, but you have to re-authenticate in order to, send a larger amount or something like that.
Exactly. And a big part of this transaction firewall is the daily spending limit. And because you have a different key for each app, we can even set like a broad daily spending limit for the whole account. And then we can, say the user's using CryptoKitties, so that would fit under their broad, $100 a day spending limit, but then with Uniswap, they might be a heavy user and they could up that spending limit to say $1,000 a day because they use Uniswap very regularly and might be trading actively.
Okay.
But
then, on a per app basis?
Yeah. But then if they wanted, if an attacker saw that, this key has $1,000 daily spending limit and they were able to somehow get access and compromise the user's computer to steal that key, they would only be able to use it for Uniswap and they wouldn't be able to just send the user's funds out of their wallet.
Okay. Wow. Yeah, that's incredible. Yeah, Chris, that's awesome. I'm really impressed by everything that you guys have done. So, for developers, is there anything else in particular that you want developers to know if they want to get started with this? Like, are there, types of projects that you're hoping to see built with something like this? Anything for the developers out there watching?
Yeah, so right now a lot of dApps are just built against MetaMask. If you're building a new dApp, I would really encourage you to support multiple Web3 providers, and there's some really cool tools that are coming out that aggregate a bunch of options, including ourselves. So if you take a look at Web3 Connect, they provide a really cool tool that you just integrate it. It's one point of integration, and then gives you a bunch of options, including Ethereum. And then also, if you check out Block Native, they're also working on a really cool solution that should be live very soon.
Very cool. And that also aggregates other Web3 providers? Is that what you're talking about?
Exactly. And then if you want to give your user a mobile experience, Ethereum is one of the only Web3 providers that will allow your users to use dApps on mobile without installing a specialized crypto browser.
Wow, that's incredible. Yeah, very cool. Well, Chris, I'm very impressed by all the hard work that you all have done. You've clearly thought this problem through end to end. Seems like every edge corner case has been considered. So great work on this, really.
Thank you.
Awesome. So before we kind of wrap up here today, when people want to get started, where do they find Ethereum? Exactly how do they get started, like downloading it, and where can they find more about you? Can they reach out to your team? How does that work?
Sure. So you can check out our site at authereum.org. We have a demo live, and you can start integrating with mainnet. And so we'd love to have more launch partners for when we open up our wait list. So right now we already have support for a few dApps, and we're always looking for more. You can contact us through the contact form, or you can email me directly at chris.winfrey@authereum.org. And then we have some docs up. If you want to read more about what we're doing, we post a lot on Medium. You can check out the code on GitHub. And yeah, would love to talk to any dApp developers that are looking to integrate. And actually, I just thought of one other pain point of dApp development that I think we have a really strong solution to. And so what we can do with contract-based accounts is batch transactions. So if you're a dApp developer and you're looking to interact with ERC20 tokens with your application, this is one of the most common points where the user actually has to make multiple transactions just to do one single action. And so with a lot of dApps, what you're going to see is approve and then transfer. And you first click approve, and then you are able to transfer your tokens. And you have to wait for 2 block confirmations, and it's a really foreign experience for a lot of users. But with contract-based accounts, what we can do is batch those transactions together. So that on the dApp side, it just shows as a single button, and both of those get mined in a single transaction in parallel, and then the user can just approve and transfer one step, one transaction, one block time. That will solve a major pain point for dApps.
Wow. So the contract that governs the accounts in this case, does it have to know about the functions that are being called in the batch? For example, like in an ERC20 case, does the actual source code of this smart contract based account know about the ERC20 functions, or can it understand them dynamically if you're working with a new contract that has to, have batch calls?
Yeah, so we've wrapped everything in a Web3 provider. So we'd like our Dapp developers to interact with Ethereum directly through Web3. But right now, Web3 does not have send multiple transactions or send batch transactions. But actually, just last week, we proposed that this be added to the it's EIP 1193 for the Web3 provider standard. It was very well received, and so I think that soon we'll have support for Web3.send multiple transactions or Web3.send batch transactions, and then different wallets can handle that in different ways. So with MetaMask, that would pop up as approve this transaction and then approve this transaction separately in sequence, and then. But if you have a contract-based account, those would get batched together, but in a way that the Dapp developer doesn't really have to know about. The Dapp developer just says send multiple transactions and inputs an array of transactions rather than a single one.
Wow, that's incredible. Yeah, very cool. All right, Chris. Well, before I wrap this up here, any last words?
No, if you're interested in hearing more, please reach out. We'd love to talk to you. And yeah, really appreciate you having me on the show. This has been great.
Yeah, this is awesome. Like I said, totally sincere when I mentioned that y'all have done great work with this. Clearly, have thought this through. A lot of talent on the table here to solve a problem like this. So I'm really excited for people to use this. Guys, go check out Ethereum right now. Go join the wait list. This is a game changer. So, Chris, thanks for coming on the channel today. Everybody, subscribe to the channel if you haven't already. Click the like button down below. Go check out Ethereum. All right. Until next time, thanks for watching Dapp University.
Take care.